Quadratic function applications. This one is involving geometry. So a farmer wants to fence off a rectangular pasture along a river. There's no fence required on the river side of the pasture. There are 100 yards total of fence available to be used. What are the dimensions of the pasture that encloses the maximum area? So here's your rectangle right over here, and then there's no fence on this side, on the river side. So you just have x, a y, and another x over here. So there's two x's and a y with no fence on this side. So the constraint equation that ties x to y is there's two of these x's plus one of these y's adds up to 100 yards. The optimizing equation is the area equals x times y. That's the area of a rectangle, x times y. So A is called the area. So we're going to follow the procedure. We solve the constraint for y. The constraint is 2x plus y equals 100. So y solves this way by subtracting 2x from both sides. You sub into the optimizing equation. Here's the optimizing equation. A of x equals x times, and you sub the y right in there because y is negative 2x plus 100, and there's the y, and just put it right in there. Then you multiply it out and you get your optimizing function, which is, because of this negative sign, it's a parabola opening down, which means its vertex will be the maximum. So doing it by hand, get the vertex formula, plug in the B and the A, and you work that out. You get 100 divided by 4 is 25 yards. And then you find out what the area is there. A of 25, negative 2 times x squared plus 100x, and that you multiply that out on a calculator and you get 1250 square yards. So the vertex is 25, 1250. We're going to find the y. Y is negative 2x plus 100. So put in the x of 25. Work this out. 100 minus 50 is 50 yards. So the answer is the maximum area that can be enclosed is 1250 yards, achieved when the rectangle has dimensions 25 yards by 50 yards. Alright, now let's do the calculator method version of this. So your optimizing function was this. You put it in the calculator to graph it. When you use zoom standard as like you normally have a habit of doing, nothing shows up at all. So what's going on? It means your window is not set right to see this function. So we suggest cranking the x max up to 100. Why? Because there's only 100 feet of fencing available, so x couldn't be any more than 100. I'm sorry, 100 yards of fencing available. So x tops out at being 100. And when you put 100 into this equation, you're getting pretty large numbers over here. So just start with 1,000, then you can crank it up to 5,000, 10,000. But start at 1,000 and you see this. So it's chopped off here. We don't see where the vertex is. So we need a little bit more in the y. So we crank it up to 1,500. You could go to 2,000. It'd be okay. So I cranked it up to 1,500. Now I see what I want. I see the vertex. So I do a second calc max. That's second calc max, and that finds me this vertex right there, and it shows me it's 25, 1250. Okay, the same as we had before. So the max there is 1250 yards, x is 25 yards, get the y the same way. constraint, plug in the x, get the y, answer the question. The same answer as we got previously. Dimensions 25 yards by 50 yards. Maximum area enclosed 1250 square yards.